Okay, illustrative math, Unit 4, Algebra 2, Unit 4, Lesson 14 is called Solving Exponential Equations. All right, so what's an exponential equation? Um, so I got a little bit of review here. Let's look at our goal. I can solve simple exponential equations using logarithms. So an exponential equation is when your variable is up here in the exponent. So I have like 3 to the x equals 12. And like here, 2 times 5 to the x equals 30. So quick little review. If I have b to the x equals y, if I want to write that in log form, it's going to be log base b of y equals x, equals that exponent. Okay, so I could rewrite things, if I gave you like, I don't know, like 9 squared equals 81, I can always rewrite that as log base 9 of 81 equals 2. Okay, these are the same thing. They're just different forms, okay? So here's an exponential equation. So right now, the only way that we can estimate a value of x is to kind of trial and error it. So we know that 3 squared is 9 and 3 cubed is 27. So I know it's somewhere between 2 and 3. So then you just start kind of like plugging in numbers until you get something close. And that's how we would do it up until now. But what we're going to do is we're going to just say, oh, okay, if I just write this in log form, it's going to be log base 3 of 12 equals x. So this is actually an exact answer, okay? And it's solved for x. So this means 3 to what power equals 12. So this would actually be an acceptable way to write it. Now, if you have a TI-84, you can actually handle a base. The TI-84 calculator, it'll actually handle a base with E. I think you hit math and then go down to log base, and it'll give you like a log, and you can actually like type in both those numbers, and it'll actually give you the decimal. If you don't have a graphing calculator, you just have like a regular scientific, you're going to change the base to 10. You're going to type in, there's a formula that's log base b of a. If I have that, it's going to be log base m of a over log base m of b. So as long as you change the base to be the same, you can type in your calculator. So we usually change it to base 10. So if I just do log base 10 of 12 divided by log base 10 of 3, that'll give me the same decimal answer as this will give me if I type the 3 and the 12 in on my 84 calculator. If I just have a scientific, I could type it in like that. So I'll do it right now, log of 12 divided by log of 3. So we're going to get like 2.26. So you can get it this way or this way. Or you could guess and check, which is a lot of work. Or this is actually exact right here. Okay, same thing here. Only difference is let's divide by 2 first. So we get 5 to the x equals 15. And then if I write it in log form, log base 5 of 15 equals x. Since that's equal to x, I'm done. This is actually my answer in an exact form. So, and then you can type it into your calculator if you want, kind of like I did over here, if you wanted to get a decimal. All right, so to solve this equation, Lynn wrote the following. Is her solution valid? Be prepared to explain what she did in each step to support your answer. Okay. So it looks like here, looks like she, in that first step, looks like she divided by 5 on both sides. Whoops, what'd I do? I'm trying to change my font size and color. So it looks like she did that. So then that got her to here, and then to get to the next step, looks like she rewrote in log form. So log base E of 18 equals 3a. And then it looks like she divided each side by 3 to get a by itself. So be careful, divide the whole thing by 3. Don't just divide the 18 by 3. So there you go. So this is actually an exact answer, okay? So there you go. That is your answer. Now it looks kind of weird because we're used to getting numbers, but this is actually a number. So, e to what power equals 18 divided by 3. Remember, e is 2.718. Okay, so, all right, before I go on to the next thing, I need to add a slide here. So right there we had log base E of x equals y. I'm going to put it like that. Okay, we know that we could write this as e to the y equals x. This is log form. This is exponential form. So here's the thing, though. We don't really write log base e's like this. There's actually a different type of log called a natural logarithm. So it's ln. This would be the same thing as saying ln of x equals y. My y looks like a G, sorry. Okay, so an ln has a base of e. It's a logarithm with a base of e. We just don't write the base e. It's kind of like a common log. So if you ever see ln, you know that it's just a log base e. It's basically this, okay? So this would be in log form. It'd be the same thing. My base on an ln is e equals y, or to the y equals x, okay? It's the same exact thing as this, okay? So when we go here, we're going to have e to the 0 equals 1. So since these are always base e, we're going to use ln. We're not, instead of writing log base e of 1 equals 0, we write it like this, ln, which we know has a base of e. Okay, same thing here. You could write it log base e of e equals 1, but instead of doing log base e, we write ln. ln means log base e. Same thing here. This is going to be ln of e. So again, it's log base e of e to the negative 1 equals 1 over e. So base e of 1 over e equals negative 1. So my base is e. The e comes from right down here. We don't know. We don't have it actually written. E to the negative 2, and then it equals 1 over e to the second. So again, this is kind of like this, log base e of 10 equals x. So it's, instead of log base e, I'm just going to say ln, because ln is a log base e. All right, so the second part, solve each equation by expressing the solution using ln notation. Then find the approximate value of the solution using the ln button. So this is going to be log base e, so the ln has a base e of 20 equals m. Log base e is ln of 30 equals m. Log base e of 7.5 equals p. So now I can find, these are exact. This column is exact. And approximate will be over here. There's actually an ln button right on your calculator, so just type in ln ln of 20, and I get m is approximately 2.996, ln of 30, 3.401, ln of 7.5 is 2.015. Again, remember, what does this mean? This means back here, e to what power gives me 7.5. Remember, e is 2.718. So let's just test it out. 2.718 to the 2.015. Let's see if I get 7.5. 2.718 to the 2.015. Sure enough, it's 7.499, pretty close to 7.5. It's not going to be exact because we rounded. All right. Without using a calculator, solve each equation. It's expected that some solutions will be expressed using log notation. Okay, so 10 to what power equals 10,000? That one I can do in my head. That's going to be 10 to the 4th. This one I might be able to do in my head. Let's divide by 5 first. 10 to the x equals 100, so that's going to be 2. 10 squared will give me 100. I'm going to write this in log form. So I'm going to say log base 10, so I don't write it, of 10,000 equals x plus 3. And then from here, I have to minus 3 from both sides. So this one's going to be x equals log of 10,000 minus 3. That way it's exact. Okay, actually, in this one, you could actually simplify this. This right here is 10 to what power equals 10,000, which I already did up here. That was 4, so really it's 4 minus 3, so this is x equals 1. All right, I didn't really leave myself enough space here, so this is number 3 right here. All right, we'll go to 4 right here. So log base 10 of 10,000 equals 2x. So then this I already found is 4. So 4 equals 2x divided by 2. We get x equals 2. All right, we'll come over here for 5. I'm going to write in log form, log base 10 of 315 equals x. And I'm going to just leave it because I can't take 10 to a power and get 315. That doesn't make sense. It'll be well, I mean, it makes sense, but to get a whole number, I would not be able to do that in my head. Number 6, let's divide each side by 2. So I get 10 to the x equals 400. And again, same thing, can't take 10 to a whole number power and get 400. So I'm just going to say log base 10, I don't write it, of 400 equals x. And that's fine because it says to do it without a calculator. All right, so there's number 6 right there. 7, come over here. I'm going to probably just go right into log form. Log base 10 of 4,000 equals 1.2x. I can't take 10 to a power to get 4,000, so I'll just leave it. But I want to divide by 1.2. There's that answer. All right, let's come over here for 8. So let's divide each side by 7. So I get 10 to the 0.5x equals 10. So let's put in log form, log base 10 of 10 equals 10 to the 0.5x. So this gets a little tricky here, but this is going to be 1, because remember, what does this mean? This means 10 to what power equals 10, so that's obviously 1. Oh, shoot, I did that wrong. That equals, the exponent equals 0.5x. And then divide by 0.5. And we get x equals 2. You can always plug this back in to check here, see if you get the same thing. 1/2 times 2 here is 1. So this is 10 to the 1 times 7 is 70, and it works. 70 equals 70. Let's come over here for 9. Let's divide each side by 2. E to the x equals 8. Let's write in log form. So instead of writing this, log base e of 8 equals x, the preferred way is to say ln of 8 equals x, okay? This isn't necessarily wrong, but this is better. And last one, number 10. Let's divide each side by 10. So I get e to the 3x equals 25. So I'm going to say log base e is ln of 25 equals 3x. And then since that's not a perfect number there, I'm just going to leave it as ln of 25 divided by 3. Okay? All right, so let's take a look at this lesson synthesis. Properties of operations apply when we solve exponential equations, just as when we solved other equations in the past, and whether or not logarithms are necessary. Maintaining equality between the two sides of the equations is essential. Okay, so that kind of came out to something like this. If I had 3 times 5 to the x equals 30, well, you got to divide each side by 3 first. And then we get 5 to the x equals 10. And then we could say, okay, log base 5 of 10 equals x, okay? So this is just equation properties here. And then this is basically going from exponential form to log form, okay? The next thing, when the unknown value is an exponent, sometimes we can determine its value by reasoning. For example, 2 times 10 to the y equals 0.2. Then 10 to the y equals 0.1, so it must be -1, or by estimation. Okay, so basically that's kind of what we had been doing before. We had said, okay, if I divide by 2, we get 10 to the y equals 0.1, and then you said, oh, okay, you can kind of think of this as 1/10, and you can say, oh, if this is -1, that would flip it, and that would work, okay? The other thing that we've been doing here is we've been just plugging in numbers until we get it close. That works, but it's not exact. All right, the natural logarithm is not fundamentally different than other logarithms, even though the notation commonly used is ln, though log base e is also sometimes used, and the base involved is expressed as a letter instead of a number. The relationship between the base, the exponent, and the value of the exponential expression is still the same when the base is e as when it's 2, 5, 10. So basically, if I have, log base 3 of 20, okay, that's saying 3 to what power equals 20, okay? If I have ln of 20, well, that's saying e to what power equals 20. And it's important to just remember E is 2.718. So this is a constant. It's not a variable. Your variable is up here. That's what you're trying to find. All right. So our goal was I can solve simple exponential equations using logarithms. Our last thing is a cooldown here. So number 1A. So let's see here. I'm going to write in log form, log base 10. I don't write the 10 of 1,000 equals x minus 2. Now, this I can do. You could type into your calculator because your calculator has the base 10 built into it. Or you could think, oh, okay, 10 to what power equals 1,000? Well, that's obviously going to be 3. So I replace this with 3. And then I have to add 2 to both sides because your equation properties still hold true. So I get 5 equals x. So 1b, 4 times 10 to the x equals 88. I'm going to divide each side by 4 to get started. 10 to the x equals 22. And then I'm going to write in log form, log base 10 of 22 equals x. And then I'm just going to leave it like that because that's exact. Now, if I wanted to type into my calculator, I could type in log of 22 and I could get a decimal as well. All right, over here for number 2, solve this equation. So I'm going to get it out of log exponential form. E to the t equals 120. This is an exponential form. I want to just rewrite in log form. So log base e of 120 equals t. Shouldn't write it like that. I'd probably write it as ln has a base of e. And there you go. And that's exact. And I could type it in my calculator to get a decimal. All right, that's it for this lesson. I hope you enjoyed and thank you for watching. We'll see you next time.